Hey everybody, this is Larry. This is day 11 of the Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's poem. Here, I just realized that I'm not wearing a shirt, but don't mind that. I was outside and it was pouring, so I took a quick shower, kind of, and then anyway. It's not important. Let's focus on the poem. Let's focus on the math. Let's do it. Today we have 2779. I don't know. Maybe I don't know much. Anyway, maximum beauty of an array after applying operation. Oh man, just one of those days where I'm losing my mind. Apparently, I'm old. It happens. You're given a zero index array nums and a non-negative integer k. In one operation, you can do the following: choose an index I that you haven't chosen before. That means that, in theory, yeah. So the keyword here is that all that means is that you can choose a subset. Like, this is a weird way. Like, you could choose an index I that I haven't chosen before and apply the operation any number of times. What that put together just means choose a subset of the numbers, and then you can replace num sub I with any integer num in the range num sub I minus k and num sub I plus k, right? Okay. What is the beauty? The beauty is the array of the longest subsequence consisting of equal elements. I mean, I think that's pretty. I think there are a couple of ways you can think about it, possibly. I mean, my first idea is maybe honestly try to do some sort of binary search, but I don't see it immediately, only because it doesn't have that property that you would want from binary search, right? And what I mean by that is just that, if you kind of think about, or if you, maybe it's just not possible, right? Like, there's no monotonicity and stuff like that, so just very basic things. The way that I would think about it, and it's kind of I feel a little bit weird about this problem, only because I felt like I've done something recently on the contest, but the number is 2779, so it doesn't feel like it. But I'm bringing up the drawing board anyway, so hang on. Give me a second. Where my pen at? Oh, there it is. Okay, yep. Yeah, and also, yeah, while I'm here and while I have your attention, let me know. So I got a new mic stand. Let me know if it sounds a little bit better, a little bit worse. Either way, well, I'm playing with it now, so maybe now is not the right time, but I'm adjusting it a little bit. But yeah, let me know, because it costs me money. I would like it to work. It would be nice. But yeah, okay. So the idea is that, okay, so you have some numbers. For example, I'm looking at example 1. You have, let's say you have some this terrible line. Let's say you have the axis, right? And then you have like 4, 6, 1, 2, right? So you have this is 4, maybe this is 6, this is 1, and this is 2, right? And maybe there should be points, but in either case, and now you could add or subtract some number k, right? So that means that you have some segment that you can kind of move this around, and for every number you can move it at any like every number you can move it the same k. I think my drawing is off and not to scale, but you get the idea, right? So maybe there are like a couple more, right? And then the idea is that the maximum number that has subsequence. So subsequence, we don't even have to care about the original order because it's a subsequence, right? So that means that you draw a line, right? Visually, maybe that goes through as many points as possible. Because another way to interpret this is that, okay, you start with this point, you move it to this point, right? You start with this point, you move it to this point. This point, you move it to this point, and so forth, right? So then now the maximum beauty, or whatever they call it, is going to be just like the maximum overlaps of these things. And then now, if you want to think it of another way, then now you can just think of it as sweep line, right? So this is the line that we care about, and we want to sweep from bottom up or something like this. But another critical thing is that, and without loss of generality, we can kind of reduce this to like a case analysis on 2 numbers, say, right? I mean, maybe there is a loss of generality, but you can prove stuff with induction. But we could do a case analysis, a very quick case analysis, right? So we know that k is constant, so that means that there are really a couple of cases. One is that this is kind of terrible, but okay, fine. It overlaps in this way. So then in this way, right? Then if you kind of look from bottom up, the number of overlaps changes here, and then here, and then here when you get out of the range, and then here, right? The middle almost doesn't matter, but and kind of the same idea. If you want to kind of think of, if you could probably prove this more another way or rigorously, but you could also just prove it like another way of like, okay, well in this case. So my point of with this is just that all the interesting points are at the plus and minus k is what I'm trying to say, right? Yeah, and that's really the thing. And if that's the only point that we care about, then now we can do the sweep line knowing that we only care about those points. So yeah, so that's basically it. So then now we have 4x in nums. Maybe I always like to call them events because that's how I think about sweep lines, is that you have a sweep line and then it runs into events and stuff like that. But that's just a Larry note thing, and that's more of a computational geometry thing, so I wouldn't worry about it that much. So we add two things, right? So these are the events, but we can also just like add maybe like or actually I think I used to do this like this, and it's fine, you can do it this way. But the reason why I used to do it this way, and I still kind of do sometimes depending on the stuff, is because get this, I'm old. But also what I mean by that is that there were no hash tables in the standard libraries, not usually anyway. Not ones where you could sort or anything like this. Because way back when I was starting out, C++, you didn't use ST, the standard library, just because it wasn't performant enough for competitive programming back then. So people just didn't use hash tables. There was hash tables in C, but that's a mess, and you can't sort on the keys anyway. I mean, you can, but it's not like as part of the library, so I guess you can. I mean, you could do anything you want, right? It's just about the amount of effort. But my point is that as a result, I just didn't really do it that way because it wasn't easy to do. But now, how I would write it, and I still kind of sometimes have to catch myself, so my apologies, is kind of do something like this where I find it a little bit easier. And the reason why is because then now everything is more precise in that I don't have to worry about how tiebreakers work, is what I mean, right? Because you're processing all the same events at the same time, you don't have to worry about how time events work, right? The tie-breaking events. And actually here, we're going from small to big, so here this is the ending. And I think I actually want this to be +1, because if you think about the tie-breaking, right, then now you want to, if they happen at the same time, like if you have two different indexes, 1 + 1, 1 - 1, how do you want to handle that? Well, in this case, they actually match, right? So that means that we want actually to be inclusive on the outgoing side. And I think as long as you're consistent, it should be fine, right? And yeah, and now the way that I can do it is that now I can just sort. That's not true. What I can, sorry friends, for key in sorted events.keys, right? And this basically allows us to just sort the keys, what it sounds like. So now for key, so that allows us to do a sweep line on the events more organically. And now we have a list of stuff that we care about, like, or at the same place. So then now we can just do we don't even care about, I thought maybe you need to care about the index, but maybe not. Maybe I'm wrong. Because then now, but with these events, that's the beauty, is that, you can think about it later, I suppose. D for delta in events of k, and then just do, right? As long as you handle all the same events at the same time, you should be fine. And I guess in this case, we could clear it up a little bit, right, afterwards. But yeah, and that's pretty much it. It turns out we don't have to care about each index, so and we don't have to index anyway. I forgot to write it, so we can just write +1. But also, as a result of this, you notice that this is just a prefix something, because what we're going to do here is sum it all up, which I didn't recognize, honestly, because I don't know. I am a little bit whatever today. So that means that we can actually replace this list with a counter, right? And then now you can just do and then right? And then now from this, we can just do event sub k. And that's pretty much it, hopefully. If not, then we'll have to take a look at it. But yeah, is there like a -1 or anything funky? No, sounds okay. So let's give a quick submit. And that's Gucci. And that's it. That's all we have for this one. Pretty straightforward. Why did I do it 3 times last time? Oh, I tried to do it this way. Why is this wrong? Oh, is it? No. Oh, this is just weird, actually. Weird prefix sum. Okay, I buy that. I could see why that is wrong. Yeah, this is more like it, except for I guess I actually don't count negatives, but you can also prove that at 0 it doesn't really matter. So like, because no numbers outgoing side is negative, so that's why it matters. And then you just do the prefix sum, which is kind of what we did actually. So yeah, and then here, and then this is the way that I end up doing it, which is actually very similar to what we did. And yeah, and that's the analysis, I guess, for the same reasons that we had before today. Right, we sort on the keys, and the number of keys is going to be the number of oh, this is actually bad because I reused this k. Like, it's a little bit confusing. So let me actually rewrite this as key real quick. But yeah, what's the complexity here, right? Well, for each number we have 2 events, and this is just sorting. So this is on the keys, and there's at most 2 times n events. So or keys, so there's going to be 2 times n log n or n log n, right? So that's all of n log n, right? And yeah, that's pretty much it. Space, this is also going to be all of 2 times n. I don't know what was I writing here? Was I just wrong? Or would I? No, I guess I don't talk about a complexity on this one. Maybe I talk. Oh, this one's the one that I talk about. I had this thing. I was like, I don't get it. Where's the R coming from? But yeah, but I guess here we can reduce the R as well. So yeah, that's all I have for this one. Let me know what you think. Thanks for watching. And yeah, stay good, stay healthy to your mental health. I'll see y'all later and take care. Bye bye.